Hello students, today we will be learning about the electron distribution in different shells or orbits, and this is the topic of this very chapter, which is the structure of the atom. Now let us just revise what did we learn in our previous video. So we learned about Bose model of atom and we also learned about what are neutrons. Okay. Now what did we learn in our last lecture about the Bose model of atom was that this very model, that is the Bose model of an atom, explained the movement of electrons around the nucleus in fixed orbits, or what we call is shells. So these orbits around the nucleus that we see here are associated with the fixed energy, and therefore they're also known as energy levels. Now these energy levels are represented by n, which is an integer. So this is termed as principal quantum number, and this very quantum number gives an idea about the relative distance from the nucleus. We have already covered this in detail in our last video. Now this very number, that is n, can have any positive integral value starting from 1, 2 till infinity. Now when we have n is equal to 1, which is this energy level, now this is closest to the nucleus and is the lowest energy level. So we are just giving a quick revision here. So this very picture of Bose model of an atom shows the energy levels in an atom. So these orbits that are associated with energy and are termed as energy levels, now they are represented by n. Okay, and this is n is equal to 1. This is n is equal to 2, that is the second energy level. This is n is equal to 3, that is the third energy level. And this is n is equal to 4, that is the fourth energy level, and so on and so forth. We have these orbits where the electrons move around the nucleus. Now these very numbers, now they are assigned letters as their names. So this is known as the K shell when the value of n is equal to 1. Now for n is equal to 2, the name of the shell is designated by letter L. So this is known as the L shell. For n is equal to 3, the letter that is assigned to this very orbit is M. So this is known as the M shell. And this, that is n is equal to 4, this very orbit is assigned the letter N. So likewise, we have these letters that are assigned to the different energy levels. So this is K shell, this is L shell, this is M shell, and this is N shell. So this is what we saw in our last video. So today here in this video, we will be talking about how are electrons distributed in different orbits inside the atom. Now let us understand this with the help of model. Now, as we already learned that Niels Bohr in 1913 proposed a new model of the atom, which postulated that an atom contains at the center a positively charged nucleus around which the electrons revolve. So if this is the atom that we see here, now the center of this atom has a positively charged nucleus around which the electrons are known to revolve in specific orbits. And these electrons revolve in orbits only at certain distances from the nucleus. Now these distinct orbits are given shells numbered as we just learnt 1, 2, 3, 4, and they were designated with the letters K, L, M, N respectively, moving outward from the nucleus. We also know that each shell is associated with an energy level. Now, and the third postulate that we see here about Bose model of an atom states that electrons can jump from one shell to another, gaining or losing energy in the process. So what do we mean by that? So let us just understand this. What do we mean by that? So basically, electrons, now they can move from lower energy level to higher energy levels by gaining the energy that is required in doing so. And when these electrons, they come back from higher energy level to lower energy level, it loses energy in this process. Now we know that the electrons, they revolve around the nucleus in certain orbits only. Now these are the fixed orbits around the nucleus. Now these are given by shells K, L, M and N, where K is the first energy level. As we know, each shell is associated with an energy level. Okay, and L shell is the second energy level, M is the third energy level, and N is the fourth energy level. Now what are we going to do next? We know that electrons revolve in these orbits, but the question arises that how many electrons are distributed in each of these shells? Okay, so let us find that out. So let us first calculate how many electrons are distributed in the first energy level, that is the K shell. Now note that maximum number of electrons that can be present in a shell is given by 2n square, okay, where n we know is the orbit number or the shell number, or we can also say energy level, which can take the value of an integer, that is 1, 2, 3 and so on. Now we know that for K the value of n is 1, right? So we will substitute this value in this very formula like this. So 2 into n square, that is n is equal to 1, is substituted at the place of n, which gives us the value of maximum number of electrons that can be accommodated in K shell as 2. So here we can see that we have 2 electrons that revolve in the very first energy level, that is the K shell. Now let us calculate the number of electrons that are distributed in L shell. For L shell, the value of n is 2, right? So substituting the value of n in 2n square will give us the maximum number of electrons present in L shell as 8. Now here we can see that the second energy level, that is L shell, has 8 electrons, okay? What about the third energy level, that is the M shell? Now for M shell, the value of n is 3, right? So substituting the value of n as 3 in 2n square will give us the value of maximum number of electrons that can be accommodated in this very shell, that is M shell, as 18. So M shell has 18 number of electrons. So the maximum number of electrons that can be accommodated in M shell is 18. Now let us find out the maximum number of electrons that can be accommodated in N shell. So for N shell, we know the value of n will be 4 because it is the fourth energy level. The value of n will be 4. So substituting the value of n as 4 into n square will give us the maximum number of electrons that can be present in N shell as 32. So note that the maximum number of electrons that is given by the formula 2n square will help us determine how many electrons can be distributed in each of these shells. So let us just revise. For K shell, we obtained 2 electrons. For L, we obtained 8 electrons. For M, we obtained 18 electrons. And for N, we just saw we can have maximum number of electrons as 32. Now let's see the overall picture of the atom with all these 4 shells which are combined into this. So when we have a combined picture, we can see that the electrons, they revolve around the nucleus in specific orbits, that is specific energy levels, which are assigned as K shell, L shell, M shell and N shell. And we just saw that how many electrons can be accommodated at max in each of these shells. Now let us test our knowledge. So we know that we have several elements, okay? And let us just find out how a lithium atom will look like, okay? But before that, let us understand a concept that talks about the electronic configuration of the element. Now, what is electronic configuration of the element? So, the distribution or arrangement of electrons that we just learned in different shells of an atom is called the electronic configuration of the element. But have you ever wondered why we need to study electronic configuration? It is actually very important as it forms the basis of periodic table. The periodic table, we know, has so many elements that are arranged in different periods and groups. When we have talked about periodic table, why not take a look at this? So this very table that we see here is the periodic table that we just talked about. We can see here the elements are arranged in different periods and groups. Now, what is a period and what is a group? Now, period is the horizontal row that we see here. And by column, we mean the vertical, and by group, we mean the vertical columns. Now, they are termed as groups. We will study about periodic table in very much detail in our higher classes. But for now, we need to know that the horizontal rows are known as periods and the vertical columns are known as groups. So, the elements are arranged in periods and groups. So coming back to the thing that we were talking about, that why is it necessary to study electronic configuration? Because as it forms the basis of periodic table. Okay, so electronic configuration helps us to basically understand the arrangement of elements. It also explains the formation of chemical bonds between the atoms. Now, the arrangement of the electrons in the different shells should be such that it should have maximum stability. And what does that mean? It should have minimum energy. Now, every atom wants to attain stability. We know that, right? And when atom is stable at its maximum, it means it has minimum energy, right? Now, for this, electrons will first enter into the lowest energy level, that is the K shell. And when it is completely filled up, then only the electron filling will take place in the next energy levels. Okay? So there are certain rules to write down the electronic configuration for the first 18 elements. Let us just take a look at those rules. Now, the number 1 rule is that the total number of electrons present is equal to the total number of protons. Okay? And rule number 2 says that the maximum number of the electrons that can be accommodated in any shell is given by the formula 2n square. We already learned that. Now, the third rule, that is a very important rule, is that the electrons will not enter into next energy level unless and until the inner shell is completely filled. Okay? Once the inner shell is completely filled, then only the electron filling takes place in the next energy level. Okay, so let us take up this fun game which will help us determine the electronic configuration of lithium. Now let's take a look at the periodic table to know where is it placed. Now the lithium is placed in second row, that is second period, and first column, that is first group. Alright, the atomic number of lithium is 3, and we know that the atomic number gives the number of protons. So what do we see here? Now we have been asked to enter the number of protons present in lithium. So we just saw the atomic number of lithium as 3, so we will enter 3 here because atomic number gives the number of protons. So lithium has 3 number of protons, so entering 3. Next up, we have to enter the number of electrons present in lithium. Now we just learned that the number of protons is equal to the number of electrons, and thereby the atom is electrically neutral, right? So here we will have the same number of electrons, that is 3. Now we know that the maximum number of electrons that can be accommodated in a shell is 2n square. Okay, now we have to enter the value of n for the first shell. We know it will be 1. Now this formula 2n square will give us the maximum number of electrons that can be accommodated in shell number 1, that is first energy level is 2. Now the first energy level is which shell? Of course, it is K shell. Okay. Now what do we have to do? We have to drag the appropriate number of electrons below to the orbit. Okay, let's do it then. Now we know we have 2 number of electrons that can be accommodated in K shell. Okay. So let's drag 2 of these electrons into this shell. So are we done placing the electrons in this very shell? That is K shell? Yes, we are. Now, lithium atom has how many electrons? We just learned it has 3 electrons, okay? And we have filled up 2 electrons. So we will have another shell in this atom, okay? Atom building is still not completed. So let's select this, this very atom has another energy level. So the value of n will be entered as 2 because it is the second energy level. Now for the second energy level, the maximum number of electrons that can be accommodated here is 8, alright? Now click on appropriate shell. The next energy level is assigned the letter L. So this is the L shell, that is the second energy level. Now for lithium, how many electrons do we need more? We need just 1 more electron because 2 are already present in the first energy level and we just need 1 more electron in the L shell. So we are done placing the electrons in this shell and the atom building is completed for lithium. Can we write down the electronic configuration of lithium? Of course we can. Why? Because K shell has 2 number of electrons, so placing 2 here. And for L, we have 1, so placing 1. So this is how the electronic configuration of lithium is determined, where it is given as 2, 1, where K shell has 2 electrons and L shell has 1 electron. Remember that the maximum number of electrons that can be accommodated in L shell is 8. Let us find out for carbon atom now. Let's take a look at the placement of this carbon atom in this very periodic table. So it is 6. Okay. So how many number of protons does this carbon atom have? It has 6 number of protons. And how many electrons will it have? It will have 6 number of electrons. Why? Because number of protons is equal to number of electrons. Now we have to enter the value of N for the first shell. It will of course be 1. Now how many electrons can be accommodated at maximum in this very energy level? 2. So the very first energy level is of course the K shell. So placing 2 electrons that this shell at maximum can have. Now out of these 6 electrons, we have already filled up 2 in the very first energy level, and this is the maximum that we can give to the K shell according to this very formula. Alright, we are done placing the electrons in this very shell. Now, does the atom have another shell? Of course it has, because we need to place 4 more electrons, and that will be placed in the next energy level, that is the second energy level. So placing 2 for the second shell, and at maximum it can have 8 electrons. So the next energy level is the L shell, and we need to place 4 more electrons in the next energy level, that is the L shell. So we are done placing the electrons in this shell, and the atom building of carbon is completed. Now can we write down the electronic configuration of carbon atom? Of course we can, where the K shell has 2 electrons and the L shell has 4 electrons. So this is how we determine the electronic configuration of carbon atom, where 2 electrons are present in the K shell and 4 electrons are present in the L shell, because the total number of electrons present in the carbon atom is 6. Now let us find out for the last example that we have here for chlorine. But before that, let us look at the atomic number of chlorine atom, which is 17. So chlorine atom is placed in here. So how many number of protons does chlorine atom have? It has 17 number of protons. Now it will have 17 number of electrons as well. Entering the value of N for the first shell will be 1, which can have maximum number of electrons as 2. So the K shell will have 2 electrons at maximum. So placing 2 electrons in the K shell. Next, we will have, of course, another shell. So the second energy level we will have as N is equal to 2, which will have maximum number of electrons as 8, which is obtained by this very formula 2n square. So L shell, that is the next energy level, will have at maximum 8 number of electrons. So let's place 8 electrons here in the L shell, because we have to fill in 17 electrons, where 2 electrons are acquired by K shell and 8 electrons can be accommodated in next shell, that is L shell. So we have already placed the maximum number of electrons that can be accommodated in each of these shells, that is 2 in the first shell, that is K shell, and 8 in the next shell, that is L shell. We have in total now 10 electrons that we have already placed. And we have to fill 17 electrons in the chlorine atom, right? So how many electrons do we need to place more? We need to place 7 more electrons, right? But that will be placed in another shell. So the next energy level would be 3. So placing the value of N for the next energy level as 3, which will give us the maximum number of electrons as 18. So this will be the M shell, that will be the third energy level. And how many do we have to place? We have to place 7 number of electrons. So let's do that. 1, 2, 3, 4. Placing the 5th electron, the 6th electron, and the 7th electron. So the atom building is completed for the chlorine atom, where we have 7 electrons in the last shell, that is the M shell. So can we now write down the electronic configuration of chlorine atom? Of course we can. Now, starting from the first energy level, that is the K shell, it has 2 number of electrons. So placing 2 here. Then we have 8 electrons that are accommodated in the L shell, that is the next energy level. Then we have 7 electrons in the M shell. So the electronic configuration for chlorine atom is also determined like this. So it is 2, 8, 7. Alright, so likewise, keeping the rules in our mind, we can determine the electronic configuration for all the first 18 elements that are placed in the periodic table. So this brings us to the end of this video where we talked about the distribution of electrons in different orbits. Now let's just revise. The very first shell, that is the K shell, can have at maximum 2 number of electrons. The next energy level, that is n is equal to 2, which is assigned the letter L, can have 8 number of electrons at maximum. What about the next energy level, that is the M shell? It can have 80 number of electrons, and n, that has the value of n is equal to 4, will have 32 number of electrons at maximum. Now in our next video, we will be talking about another important concept in chemistry, which is valency. Thank you.